Hello everyone, welcome back. This is the 6th video in the series where we're making Meteor Galaxy. In this video I'm going to show you how to make kind of an outer force field boundary to the world, so it's not going to be an infinite size, it's going to be kind of a closed space with the force field around it. So let's get into the programming. There are just a few things I want to point out before we start writing the code for the force field, and that's I realized that when we initialize scroll X and scroll Y, the offset at the beginning actually has to be negative, and it has to do with how the scroll direction works. Things work kind of backwards since you're moving the world versus the ship. And then remember, we have this offset here instead of just initializing to 0. We want to be able to use scroll X and scroll Y to determine where the position of the ship is. And so I put in this offset right here since the ship is at 0, 0 at the beginning. It's actually at the center of the screen, so we have to take that into consideration, but then negative because of the scroll direction. All right, the next thing I want to point out is we have all this variable initialization up here, but later on we're going to want to run the game multiple times without actually clicking the run code button. So it'll be run again through its own menu system within the game. And so what I'm going to do is actually grab these variables right here that we're initializing, and then down in our init game, I'm going to put the initializations in here. So I'll actually do those at the top right here. Then I'll go ahead and get rid of where I declare a new variable here, since we are just reassigning a new value to an already existing variable. All right, the next thing I want to do is so right here we add the stars, and I realized that because we're adding the stars after we put the ship on the map or on the canvas, it means that the stars were added later, so they'll be on top, and that doesn't look quite right because the stars are more in the background. So I'm gonna put the stars, add stars right here. Before we write the code for the force field, I want to talk a little bit about the game design theory that goes with it. So Meteor Galaxy is a very fast-paced game where you're flying at high speeds and then launching the laser beams at meteors. And what we don't want is to ever lose that sense of always moving in fast speed. And if we had just a hard wall that was the force field, you'd hit it and then you'd have to back up and then turn around and then get on with the game, and that kind of takes away from that fast-paced nature of it. So what I'm going to do for my force field is, instead of having it be a hard wall, it's actually kind of have some springiness to that, meaning when you fly out, it's going to act more like a slingshot and kind of launch you back into the game, but also spin you out of control. So that way it has some consequence to it, although you can turn around your ship quickly if you fly into it, if you need to do that. So there's a little bit of strategy there too, but it adds more to the game, I think, than just having it be a hard wall. Now let's write the code for the force field. I'm going to set it up in a similar way that I did the stars. So there's going to be a function that adds the force fields in the game, and then another one to move it around. So to keep my adding functions all together, I'll just put it right underneath of the add stars. So this is where we're going to set the function. So function add force field. Before we write this, we need to declare a new array. This is going to hold all of the rectangles within the force field. So the way the force field will work is we're going to have rectangles that are transparent in the center, and they're going to be nested within each other. So we're going to have a smaller one right at the perimeter of the world, and then they'll get larger and larger as they go out, and then those will all be stored in this array. So I'm going to go to the top here and declare a new array. This one is going to be called force field rectangles. And I'm just going to initialize that to an empty array right here. And then down at the beginning of this add force field, this is going to be called at the beginning of the game. And so I'm just going to initialize it to an empty array here, so that clears out all of the old force fields and then makes them fresh. Next, we need to iterate through and create all of the rectangles and then add them to the force field rectangles array so that they can be moved around later. So I'm going to use a for loop for this. So we'll set variable I to 0. I is less than the amount of rectangles we want to use, and I found 100 works. And then I++, add 1 to it. So the first thing we need to do is declare our new rectangle. So variable new rectangle is going to be equal to a new rectangle. And then inside of here, we give it the width and height of the rectangle. So I'm going to set this to the world width and the world height. And that way it's going to get bigger from there, but I'll just set it up this way for now. And so it'll be right on the perimeter of the world. Next, we need to set the position of the rectangle. So new rectangle dot set position. And this will set the position of the upper left-hand corner of it. So we're going to want to put that, at least for the first rectangle, it'll be right at the upper left-hand corner of the world. So this will be world top left X, and then world top left Y. Now that we've got that, we need to change some of the properties of the rectangle. So since they'll be transparent in the middle, we're going to have a border on it so that it'll just kind of have lines that make up the force field. And then that way the inside will be transparent and it won't block everything that you're trying to see. So to add a border, we can say new rectangle dot set border. And this takes in a Boolean, and we want this to be true since we do want the rectangle to have a border. The next thing we need to do is set the width of the border. So set border width. So I'm going to use 8 for that. The next thing we need to do is set the color. So new rectangle dot set border color. And then I'm just going to use the default green color, but of course you can use any color that you'd like here, whatever you think looks cool. And then the next thing I need to do is make the inner part of the rectangle transparent. And there is this method in the CodeHS documentation called setFilled, but I was having issues with that. It wasn't making the inner part transparent when I set filled to false. So what I'm going to do is say new rectangle.set color. As I mentioned earlier, you can pass in a hexadecimal color as the value to set the color to. And so right here, I'm just going to pass in this color, which is just transparent. And so that will make the inner part of the rectangle transparent. The next thing we need to do is add the rectangle to the screen. So I'm going to just use the add method right here. So add the new rectangle. And then the last thing that we need to do is add it to the force field rectangles array so that it can be moved around later. So I'm going to call force field rectangles and then dot push. So push to add it to the array, and we're going to give it the new rectangle. So that'll push this new rectangle into the force field rectangles array. The next thing that we need to do is make the rectangles nested within each other, since right now we'll put them all at the same position. So as we make them bigger, we're going to need to move them towards the upper left corner of the screen. So if you see my mouse pointer, it's going to be up here, and then it'll get farther and farther out as they get bigger. So we need to subtract from the position first. I'm going to space mine so that there's going to be a 16 pixel gap in between each rectangle. That means it's going to be 32 bigger than the last rectangle, since that'll be 16 pixels on each side. So for the position, we need to just subtract 16 times I, since it'll get bigger as it goes out. And we'll do the same for the Y. And then for the width and height, we need to add 32 times I, since we need that 16 pixels on each side of the rectangle. So times or plus 32 times I. Alright, so that'll make the rectangles nested within each other. Next, I'm going to write the function to move the force field around the screen, since we'll never be able to see it since it's much bigger than the canvas. So I'm going to go down past the move stars function right here. So I'm just going to keep all the movement functions together. And this one's going to be called function move force field. And it's going to move the force field in a similar way to how we move the stars, except for it's going to be at the same depth as the ship. So we don't need to worry about any depth multipliers or anything like that. But we're going to reuse this right here. So what we need to do is iterate through our array that holds the force field rectangles. So I'm going to use a for loop, initialize I to 0. I is going to be less than force field rectangles dot length, so we're accessing the length of that array since we're going to need to move each rectangle, then I++. And then we're going to need to get that rectangle from the array, so get the reference to it. So I'm going to use force field rectangles and then use the square brackets to access the rectangle at the I position in that array, since we're just going to go through all of them. And then we're going to call dot move on that rectangle. And then the amount we need to move it is the scroll x minus the last scroll x. So I'll put that here. And then the scroll y minus the last scroll y. So the change in x and the change in y on that frame. The next thing we need to do is call the functions that we just wrote. So I'm going to add the move force field to the run game function right here. So I'll put that right there. We also need to get the add force field function, and that will go into the init game right here. And you get to make a game design choice. If you want the force field to be above the spaceship, you can add that after you put the spaceship on the canvas. But if you want the force field to be underneath of the spaceship, so the spaceship on top, then you can put it before you add the spaceship to the canvas. I'm going to put mine after to see how it looks, but you can do it either way you like, whichever way looks better to you. Let's run the code and just see if the force field's getting drawn properly to the screen. We won't be able to like collide with it, although we're not doing quite collision. It's more of kind of a springy net type thing. But let's take a look. So if we fly just to the top of the screen, you can see we have this force field. So kind of this cool looking net of rectangles. Well, they're rectangles, but we're just using the border. And then I chose 100. Most of the time you won't get this far out of the map. So the force field will just kind of use the remaining space, so you won't usually see this space up here. So the force field, pretty much you'll only see force field when you leave the map. So I chose 100 since that's just a lot of rectangles to do for that. The next thing that we need to do is add a function to check the force field. So we're going to see if the spaceship is still within the boundary of the world, but if it's not, then we're going to have it push the spaceship back into the world. So let's go back over to where the move ship function is, and I'm going to put it right beneath here. And this is going to be called function check force field. All right, inside of here, we're going to need to use some if statements to do some checks. So if our scroll x is greater than the world, actually less than the world top left x. So what this means is if we're outside of the world to the left side, so if you look at my mouse pointer, it'd be over here since it's smaller this way. What we need to do here is add, since it's too small. So I'm gonna say scroll x velocity plus equals, and then I'm going to do the ship speed and then times 2.5. That way it needs to be bigger than the ship speed, or it doesn't have to be, but I think it's better to do it that way just so that you can't fight against it and get out of the map. So always be pushing harder than you can resist. Next, I'm going to go ahead and set up the other checks and then explain them to you. All right, so here what I've done is I've done checks for each side. So on the scroll X, if it's greater than the world bottom right X, since right here we're checking the left, right here we're checking the right side, we're gonna subtract the ship speed since we know that the scroll X is too big, and then I've set up something similar with the Y. The reason why I've broken this into two statements, so I've got an if else if here and then an if and then else if here, is because these two conditions can never be true at the same time. You can't be outside of the world on both sides. You'd have to have two spaceships. But the X, it could be out of bounds on both the X and Y axis. If it were, say, if you see the cursor right here, if this were the world boundary and it was over here in this corner, outside this corner, it would be outside on both the X and Y axis. And so we need to bring it in diagonally so that it comes back to the center. So we do want we do want to have the possibility of running at the same time. The next thing we need to do, like I mentioned earlier, is I want to do is spin the ship out of control, just to add more to that effect. And so what I'm going to do is add a variable called out of bounds, and that will be equal to false at the beginning. So the reason why I'm setting it up this way is we don't want to add to the ship's rotation in each of these if statements if these two can be true at the same time, because if you went out on the over here, like say out on the top left corner, it'd spin twice as fast as if you went out on one of the sides, since it'd be out of bounds on both the X and the Y axis. And I don't think that's really the right effect for this. I think it should just be a consistent speed. So instead of here, I'm going to make out of bounds be true and then add the rotation velocity at the end. So I'll just add this to the others. All right, next I'm going to add to the rotation velocity if we're out of bounds. So just if out of bounds, then we're going to say ship rotation velocity. We're going to add to that, and it's going to be ship rotate speed times 2.5, like the other ones. The next thing we need to do is add this function to the run game function so it gets called. So I'll do it just right after the move force field. All right, now we can test our code. So this is the exciting part. Got our intro. The spaceship's here. So next we just need to fly into one of the force fields, and you can see as we go out it spins us back and forces us back into the world. So it spins us around, forces us back in the world. So that's cool. One thing I'm going to change quickly, I realized that on the old one I made for the ship rotation speed is actually 0.005 for the ship rotate speed. I think that looks a little bit better since the rotation speed matches the velocity it travels at. But of course, if you like to go faster, you can, but I'm going to turn mine down to 0.005. So let's take a look at what that looks like now. So if we were to go out of bounds, it spins us and pushes us back in. And then let's try the corner. So if we get kind of lined up, go into the corner, you can see it pushes us back. So we kind of go around the corner, since both of those conditions can be true. And I think it looks kind of cool. Like it keeps that fast-paced nature if you kind of fly in the side and it pushes you around the corner. I think it looks pretty neat. Now we just completed the Meteor Galaxy force field. So it's starting to look a lot more like the finished game, which is exciting. And yeah, this was a fun video to make. I just got a capture card, and so you may have noticed the camera quality improved a bit, but I've been learning a lot by making these videos and learning how to use my editing tools better, and it's been a lot of fun. So I really enjoy making these. So that brings us to the end of this video. Thank you so much for watching. I hope you come back for the other videos. and that you all have a great day. Goodbye.